Example 1, find area between the curves y equals negative x squared plus 9x plus 10 and y equals negative x plus 10. Notice, to understand which function is above the other, well, it's important at least to be able to graph these functions when we can, right? Fortunately, by now we have many tools at our disposal from our classes in pre-calculus and those from calculus 1. The first graph is going to be a parabola because that's a degree 2. The second one is going to be a line because that's a linear equation. So the first graph is this upside down parabola. The second graph is this line. All right. Now we need to identify the intersection points. In other words, what do? We set this expression and this expression equal and solve for x. Negative x squared plus 9x plus 10 is negative x plus 10. Move the negative x over, that becomes a 10x, plus 10 and plus 10 cancel. You're left with negative x squared plus 10x equals 0. X common, negative x plus 10 is 0. This fetches me the 2x coordinates, x equals 0, and this fetches me x equals 10. So x equals 10 happens here, x equals 0 happens here. When I substitute these values in either of these equations, say x equals 0, I get y10. X equals 0, I get y10. So that's my first point. When x is 10, y is 0. That's my second point. You can check here as well. So you get the 2 points 0, 10 and 10, 0. 0, 10 and 10, 0. So area between the two curves is integration when x is 0 to x is 10 of the higher curve minus the lower curve. All right. So simplifying, negative x squared plus 9x plus 1x plus 10 minus 10. All right. You're going to integrate this expression from 0 to 10. So we are going to use the fundamental theorem of calculus. Find the antiderivative. Set limits 0 to 10. So at 10, I get these values. At 0, it's going to be 0. So eventually the answer is, oh, that's an error. It should be 466. Okay, just check my work. It should be 466 and 2/3. All right, 466 and 2/3 square units. Notice this is area between two curves. Here is